Hello, everyone. Someone still at the door? No. I want to welcome our next speaker, Luka Kladarić. Round of applause, please.
Thank you. Okay, so welcome to Tech Bankruptcy. My name is Luka. I run Sakura Collective, which is a chaos management consultancy, which is basically a very, very nice way of saying we put out trash fires for a living. So what is this talk? You've all heard of tech debt. I found better names for it, like sustainable development and so on. But tech bankruptcy is basically when you go into debt so far in that you are unable to produce new software, and where it's all bad wherever you look, and there's no clear way out of it. So what are we talking about here? Since the dawn of software development, we've been faced with the same impossible choice almost every single day. You do it quickly or you do it well. We do our best to make the right choice for the task at hand, and we move on. But then came the lean startups and the move fast and break things, and they put their thumbs on the scale in the favor of the hacks, the MVPs, the just ship it's, and the product managers just ate it up. It's great. I mean, it's great for proving a concept or finding a market fit, but what happens when that's all you do? When the entire organization, top to bottom, has collectively forgotten how to write quality software, when you become unable to make the correct technical decision, even by accident. So we'll be reverse engineering bad technical decisions. We'll take a deep dive on a mission-critical web application that is basically unusable on its best day, and trace the trivial bad decisions that got it there. In the end, I hope you will never take a shortcut again, or at least consider it carefully. So what are we talking about here? The product. Think small-time startup has a mobile application, something like Foursquare or Swarm. People download the app and they use it. They have some information in there. They put a lot of their information into it. Like you're checking into locations, you're leaving tips, and you're leaving photos for other people, and then they like them, they comment on them, and so on. It's a bunch of data that people are dumping into your application that you have no direct real use for. Maybe you sort the venues, maybe you have some like aggregated scores and such, but you're not doing anything you're not looking at individual data. The data accumulates over time and isn't really used, and this goes on for years. And then at some point, somebody says, we should do a hackathon. You know, development has gotten, the work has gotten boring. People are on a death march for shipping features, trying to get people into the app and using it and generating revenue. So you throw a hackathon. You organize a hackathon, and someone builds a concierge dashboard. It lets you peek at individual users' data and reach out to them with suggestions over chat. And everyone loves the idea. Everyone's like, why didn't we think of this? So the company actually pivots into this. The ads revenue is drying up. Nobody's buying the no ads experience, because who buys no ads? So you pivot to selling this concierge service. You start small. You have a few people working on it, providing the service and helping just a few clients that have been selected for this trial. And then enter problems of scale. The app is essentially a collection of hacks to pull user data that was never meant to be aggregated from the database. And the way that it was built was without any regard for proper software development, for proper architecture, for proper data access. It's just because the data was stored not in mind for this, with this use, the way that you access it is entirely suboptimal. So you grow when you have too many internal users. It was built for maybe a dozen people. All of a sudden you have hundreds of staff working on this app. And initially each employee is helping maybe a dozen clients. Now some of them have thousands. And it's no longer a small trusted team. you're hitting as you grow, as you have more people come in and pay you for this service, you start to realize that you cannot hire people fast enough in your city. You start to hire remote. You start to outsource to different time zones and so on to cover the entire planet. And suddenly, not everyone is sitting in your office. You lose that trust that you have of people that you can see into their screen. You can see what they're doing. And this is, you're hiring anyone who can do the job, so very difficult to establish and maintain trust there. And also supporting those users becomes difficult. Someone who has a slight problem with the app, who is in your office, you just walk over and fix it for them. Someone on the other side of the planet in a completely different time zone causes pain. So what kind of problems? Just to give you an idea, obviously I can't share screenshots of this app, but what we're basically talking about is some sort of like Facebook Messenger interface where you just have a sidebar full of users, profile photo, name. When you click them, you get their profile, you see the data that they've put in, where they've checked in, which photos they've uploaded, which tips they've left, and you can engage with them over chat. So how do problems manifest? What kind of problems do you see when you take something that was built as a hackathon after a company's existed for years, that pulls in data that was not meant to be individually displayed and cross-referenced and so on? So, number one, it's slow, timing out. And what happened to cause this? The browser can't render that many messages, but the API doesn't have pagination. So you have chat with users that just pulls in all of the messages ever. So that's fine when you're building it because, it's got 1 or 2 test messages. It's got 10, it's got 20, it's fine. Eventually, people use this. You end up with thousands of messages. So you realize that it's very slow to render a chat box with thousands of messages. So what do developers do when they don't want to disturb the backend team? They paginate in the browser. So you still fetch everything, but it's only rendering like a few messages at a time, but it's all from local stores. So you're still fetching everything, and it's horribly slow. So I don't even want to go into this anymore. Next, it's slow timing out. Backend team is busy. They can't be, they're building the product that the company has worked on for years, and you have this small hackathon team that needs tiny things. And the backend team is like, we don't have time for this sprint, we don't have time for next sprint, and so on. And suddenly someone says, just give me all of the data in an API. Just, here's which data I'm looking for. Just give me one endpoint that I can hit and get all of the data that I need to render this. It's for an MVP. It's for a demo. I need to close this task this sprint. So what happens when you do this? No pagination on lists that keep growing forever. Almost every single list that you have ever returned over an API is going to grow, unless it's 4 options, in which case it's going to grow to 6. But if it's something that accumulates with user input or user actions, that list is going to grow. So one problem, no pagination. The other problem is deep responses. If you're thinking of say Twitter API. A deep response would be if you say, give me a list of tweets, and then in the list of tweets you have the user object, not the user ID, but the user object. Twitter does this. They have good reason. But also imagine if that user object also had the tweets from that user and also had what they liked. And all of those are, again, lists. Those are deep responses. You should be aiming to keep responses to 1 level or maybe 2 levels, and certainly not have lists in sublevels. So to clarify this part, you could build a Twitter clone that has a single API that returns all of the information it knows for all tweets, all users, all tweets by each user, everything. And if 10 of your friends used it, it would work fine on day 1, and within half a year, it would no longer work. So if you have more users, that timeline shrinks. The next, it's slow / timing out. The backend team is busy. Let's just reuse this meaningless field for meaningful signals. There was an example where they wanted to run an experiment, which was the user does something in the app, and that highlights the user for the concierge. And they couldn't fit the development for both the backend and the database, and upgrading the database to allow for this field and so on. So someone said, just send it as a message of a specific, a chat with a hashtag bump me to top or whatever. And then the browser, the app in the browser will sort these people on top. It works. Again, if you have 5 users, it works. But to sort people to top based on messages that they sent, if you have thousands of people, means you need to load the chat for thousands of people, figure out which time each of those people sent that message, which time, which ones of those were responded to, and so on. Sorting in the UI based on data from deep responses just doesn't work. It fails on day 3. It's slow timing out. I don't know which one this is. This is like the 5th one. Real-time chat is difficult. It's very difficult if you have a page that loads with the chat, and then someone sends you a chat message and you add it. There's a race condition between the time when you've fetched the messages that already exist and the time when you're ready to accept real-time messages. So how do we get around this? There's difficult solutions. And there's also the very simple solution of every time you use PubSub or a WebSocket to tell you when someone sent a message, but then you trigger a full refresh of the chat. So you don't have to worry about any messages that you missed. Anytime someone sends a message, you might miss a message, but the next time they send a message, you're gonna catch up, you're gonna see that one. You're not gonna forever miss it. Combined with the things that I mentioned before, where you have fetch all of the messages so that we can sort them for all of the users. No pagination on the messages API, so basically fetching everything ever, storing it in the memory. And as the number of users grow and then the data that you're sending grows, it just becomes completely untenable as an approach. And also, if you use PubSub or WebSockets or something like that for external event-driven data fetches, please make sure that while you're fetching, another event doesn't trigger another fetch in parallel. Because I didn't even create a separate slide. It's slow/timing out is there's a huge surge of users. And all of these users are suddenly sending you messages. So you open the app and it's loading and it's loading and it's loading and then it times out. So I open it, I try and see it. My test user obviously has five people messaging me, so the error doesn't show. So how do you debug this? And I reach out to the people who are reporting that it's just completely unusable for them, and I ask, can I log in as you? Of course, we share passwords because that's how we'll get to that part. And I log into the busiest account. And what I see is it just loads, and then it fails. And I open the network panel to see what's going on. And you see fetching messages, and it's loading, and the response is megabytes big. And then as it's loading, you see another fetching messages. And once it gets like 8 wide, the first one is so slow that the last 20% just never complete, because each of these requests is starving your connection, starving the server, starving the database, starving everything of resources. So they start to kill each other, and they all time out, and the app crashes. But obviously, nobody expected fetching messages to fail or crash or time out. So it doesn't disable the app. It just throws up an error, but it keeps doing that. So you have hundreds of users experiencing this kind of issue, and when it crashes, they don't close it because it crashed. It's doing nothing, right? So they open a new tab. So you end up with people who are, you end up with 300 users who have 5 tabs of your application open, each of which is DDoSing you forever. And I'm looking at the load balancer graphs, I'm looking at the server graphs, and everything is 10 times what it was yesterday, and I cannot understand how a company that has been around for 8 years suddenly is experiencing 10 times the traffic, legitimate logged in traffic, and I realize all of that is coming from the internal application that has 300 users, not the thing that we have millions of users out in the wild. This is an example of how tiny, tiny, tiny bad decisions accumulate into something that takes down the entire site, takes down the database, causes a whole day of lost productivity because people cannot access the app. Now for something completely different, it's slow/timing out. Someone somewhere decided that they needed avatars. In the sidebar with a list of users, it's easier to tell people apart with their profile image, especially if you have people with the same name, common in these areas, but also everywhere. So we don't have thumbnails. What do? We don't have thumbnails. People upload their profile photo in full res from their phone to the system. When we have these full res photos already, the app already does that. They're already uploaded. What do? How do we backport thumbnailing? You don't. You just reference the full image and just resize it in CSS. It looks nice. Browsers are really good at resizing images. But you get complaints that the app is horribly slow on just the tiniest bit older machines. Like if you have a computer that is 2 years old, it just does not work. So I asked for someone for their password because they have the complaint. It works fine for me. I log in, it's like, no, it still works fine for me. Interesting. This could be the computer or the network or both. Pull up the network tab, disable cache, refresh. 800 megabytes on first page load. Because of course it's loading the images straight from S3, there's no caching on them, nothing, it's just like. So what do you do here? We quickly spun up an image resizing proxy. So you say, instead of going to whatever .s3./profile photo, you go to our image resizing proxy.companyname.com/S3. No. The result is 12 megabytes, down from 800. This is for a person with over 1,000 users assigned. Now, if the sidebar were paginated, so pagination is going to be the word that I mentioned the most in this talk. If the sidebar were paginated, you'd only be seeing like maybe 20, 30, 50 users, and that would be a fraction of 12 megabytes. But 12 megabytes is a lot better than 800. And it turns out this specific thing, the fact that we were loading full-size profile photos for even users that were way below the fold, that you never even see, that you never even scroll to, was the one thing making this app completely unusable on iPads. So it was kind of usable on current generation computers, kind of slow on slower computers, but completely unusable on iPads and such things. And this was the reason. As soon as we roll this out, hey, app loads on an iPad. This could have completely changed the direction of the company when it started growing. Instead of saying you have to bring your own computer, we could have just shipped everyone an iPad mini and had them work from that. Could have gone towards optimizing the app for the iPad and so on. But because it was always unusable on the iPad, nobody even bothered. That was just a direction that the company never considered because of a stupid technical decision. It's slow/timing out again. Why is everything down? So again, pagination. When you don't paginate things, your response time slowly grows. The response slowly slows down over time because you're responding with more and more data. If you're paginating, you're always responding with 50, 100, 200 records. And that's usually, fetching 200 records takes the same amount of time always, usually. Sending them from the server takes the same amount of time, and transferring them over the network takes the same amount of time. So even if there's thousands and thousands and millions of records, it always takes the same time. If your responses grow, so does the response time. Now, 20 seconds for a web request is bad, but it's not the end of the world. The end of the world is when you have a surge, when you have too many requests coming in, that 20 seconds quickly becomes 40 seconds. 40 seconds is a timeout on most common network equipment and so on. So if you go through standard load balancers on Amazon, on Rackspace, on whatever, 30 seconds, if you don't respond within 30 seconds, you're done. If your request was 2 seconds and you hit a surge and it's 4 seconds, things still work. But also, it's easy to look at it at a level of one thing timed out. Long responses mean that the process that is serving them is tied up with that one request. The next one has to wait in queue for that. So when you have a surge of slow responses, eventually you ran out of workers to service those. So a slow request will not only mean a bad experience for the user who is trying to get to that information, but it actually could cause an outage for someone else. And we are done with it's slow/timing out. We have a new section called Who Did That? We don't know who sent the user a message full of profanity. Someone was having a bad day and cursed at the user. But because there's no way to grant Alice access to Joe's account without sharing passwords, they share passwords. It's normal, it's common. People will do this. There's absolutely no way around it. Once this goes on for long enough and you're not enforcing password changes and you're not being vigilant about preventing password sharing, you will get to a point where every single person using an app has plausible deniability about who did a bad thing. I don't know, 40 people have my password. Any one of them could have logged in to my account and sent, someone doesn't like me, wants to get me fired. They logged in and cursed at a user, hoping I would get fired over this. The other one, again, we don't know who moved a bunch of users from one concierge to the other. Because this app is an afterthought, because it was never properly integrated into the ecosystem, it has its own backend. So you have the API that everyone else is using, and then it has its API that just talks to this API. Which means that all of the users, all of the whole context of who is doing what is happening in its backend, not on the main API. And the backend and the API talk and authenticate using a single shared password or token or whatever. So there's absolutely no way for the API, the one that owns the data, the one that fetches the data, the one that executes the actions, to know who requested that action to be taken. If you're dealing with messages, you know at least which user sent the message, which user-facing user, concierge sent a message. But if it's an action like cancel user subscription, or refund them, or block them from the service, or move them to a different concierge, or any action that is not that doesn't manifest itself in a message format, you just have absolutely no idea which of your 400 people using this application executed this action. Now, this could be the 50 people in your office. This could be the 150 people that are your actual employees that are remote. This could be one of the 200 people from the outsourcing agency that just rotate in and out, and you have no idea. But also, because you don't have that audit trail, there's no record of who exactly got moved. You just know that you have two concierges and they were both supposed to have 200 users each, and all of a sudden this one has 400 and this one has 0. You have no idea. You have no way of proving that it was an accident or on purpose, and you also have no idea who specifically got moved. You have to go look at who they were messaging, the context of each user to figure out where to move them back. So. API implementation 101. There's a lot of resources for how an API should look from the outside. I'm not going to go into that, REST and all of those things. I'm here to talk about data-heavy apps where the API design and implementation has to be done right, because you will rarely get a chance to refactor it. APIs, by definition, are meant to be stable long-term contracts on how different apps interact. To change an API usually requires coordination across multiple teams or at least multiple people. So what should an API look like from the inside? Paginate early and paginate often. If it returns a list that is at all likely to grow past 100 elements, paginate. If you're not sure, paginate. Unless you can absolutely be certain that your list will not be more than 5 elements, implement pagination. And if Say, here's my 5 elements on a 100 element list. So for the first 100 elements, you don't have to even implement the usage of pagination, but it's already in there in the API, the format, the response, and so on. One other thing that I would like to call out that is not related to this specifically, but if you're doing pagination, don't send a total count of elements. It's a pain. People will fight you on this. Product will fight you on this. Design will fight you on this. Front-end developers will fight you on this. But getting the total count of elements in any sort of storage, in a database or whatever you use, takes way, way, way more time than fetching any number of elements. Because oftentimes, this depends on the implementation, but oftentimes you will have to go through the entire list to figure out how many there are. So returning the first 100 messages or the last 100 messages that 2 people exchanged is, a fraction of a second. Figuring out how many messages between 2 people is a second. That's the relationship between those 2. The way to get around this is, if your API is meant to return 100 elements, say fetch 101. Fetch 1 more than you're supposed to return. And if you get 101 results, that means that there's more than 100 in the database. So you say, here's your 100, and by the way, there is more. If it returns 100, then the page that you fetched is the last page that exists. If it returns less, then just return less. Avoiding the selection of the total count, be it through whatever method you want, will save you a lot of headache in the future. The second thing I talked about is avoid deep responses. Deep responses will inevitably grow. If you have a user profile and the person has a location, I am right here now in Novi Sad. If you say user profile, current location, Novi Sad, sooner or later someone's going to go, hey, we'd like to have a tiny picture for the location or a flag or whatever, and then we could use a cover photo, and we could use this and we could use that. If you look at who liked a tweet, you could have a list of users, but then for each of those users on Twitter, you could have the name, the username, the avatar, the cover photo, how many followers they have, who their follows are, and very quickly you get into a nested hell. Deep responses are great when you're initially prototyping an app. It's very easy to say, give me all of the information that I need, and then render the UI from that. But as fields are added, as the complexity of the app grows, you quickly get to the point where things are untenable and just impossible to dig yourself out of. But whatever you do, never combine lists with deep responses. If you have an endpoint that is, give me my profile. Okay, here's all of the information about your location and so on and so on and so on. But don't include tweets in that. Don't include who you're following in that. Don't include who follows you. Pagination in deep responses is possible. It's a special level of hell. And without it, you have real performance pain. With it, everyone just hates you. Just everyone forever. Sort and filter early. There's absolutely no way to stress this enough. If you say that sorting and filtering in the database takes a second, you should immediately. So say we set this at a second because that's an amount of time that you can measure in your head. That's how much it takes in the database. If you go and filter in the backend that talks to the database, you should be thinking that that's going to take 10 seconds because that's the order of magnitude. It's that much slower. And if you have another backend talking to that backend, that's going to be 10 minutes. And if you have a browser talking to a backend that talks to the API that talks to the database, that's an hour. Now, obviously, sorting and filtering in the database doesn't take a second. It takes a fraction. So this takes a fraction. But all of these things combined, it grows, and as your data set grows, as the number of your users grow, as the number of people that you're trying to get information to grows, these things just balloon and slow down and become completely unusable. This is one that I don't see covered often, but do authentication well. Think of it really, like have a meeting and discuss authentication, discuss where you're going with this and what you want to do with this. Now, what do I mean by do authentication well? User management console. You will not believe the creative ways people try to get out of having a dashboard where you can create a user, where you can delete a user, where you can ban a user, where you can reset their password and change their permissions. I've seen things like we already have, end users, our clients that use our mobile app. So why don't we have internal accounts be regular accounts that you then somehow change? So the process of a new employee using your application is download the app, register for a free account, and then let us know what your username is so that we can send like a manually crafted curl request to upgrade that to a proper account, to a staff account. Having this when there's not much to user management, when it's literally just a list of users that you can find by username, email, or whatever, and the ability to send them a reset password thing, change their email. People lose access to their actual email often. That kind of stuff makes it way easier to add fancy features later. If you have a user management console and all of a sudden you're like, this feature should not be allowed for everyone, only certain people should have access to it. It's easy to add a permission where you can just check the thing in the management console. If you don't, you're more likely to not do that. You're more likely to go, people will just know to stay out of this. Authentication part 2. This one is, so many companies get this wrong, so many big companies, so many important companies get this wrong. But you will inevitably need to separate how your staff logs in from what the end user sees. You will have situations where one person is going on vacation, but the clients have a direct relationship with them. So Joe is going on vacation, and this user is chatting with Joe. They want to keep chatting with Joe. It's going to look silly when all of a sudden they get messages from someone else. The ability for Veronica to log in as Joe and keep working with Joe's customers is important. If you don't have the ability for access to be temporarily granted to Joe's account to Veronica, they will share passwords. And you end up with a plausible deniability scenario where nobody really knows who logged in, why, and so on. So just to explain this, you should separate application users, which is a username and a password, which is a person, to client-facing personas. That is just something that should immediately be separate, meaning you can fire a person and just give someone else access to the persona. But if you can, immediately start thinking about one user should be able to access many personas. It's not just we have these guys and it's one-to-one. You should be thinking maybe Veronica needs to access her account and Joe's and Fred's and so on. But also one persona, so one thing that your end users see should be able to be accessed by many users. Those are separate things, but it kind of goes into this whole story. This will make password sharing almost unnecessary, because if you do this and you have a user management console where you can actually configure all of this, and you have the ability, so for instance, people go on a vacation, they can nominate who gets to log into their thing, and you just have an audit trail in Slack that says, Joe nominated Veronica to be able to log into his account for a week, and that just pops in and automatically expires. People will not share passwords. You can, the solutions that I've seen are forced password changes every week, or people being emailed new passwords every week and stuff like that. This stuff is not that difficult to do initially. But if you have an app that already exists and you need this, it's hell. And authentication 3 is audit log for all destructive operations. Any destructive operation, and destructive operation is any operation that changes data in the database, especially if it changes massive amounts of data, needs to be logged with the identity of the user who did it. Not the user-facing persona, the actual person who was logged in. And people need to know that this exists. You should show it to them occasionally. They should understand that the fact that they shared their password with someone is going to be completely ignored, and that they own all actions taken by their account. Because, and here's the hard truth, you will eventually experience bad actors within your organization. This is just unavailable. Human beings, when given anonymity, are trash. That's a proven fact if you've been on the internet in the last 10, 15 years. It is very important to be able to identify them. There is a fine line between shipping features all the time and doing foundation work. Please try to find it. Now, don't take my talk to mean everything has to be perfect. I initially said I hope you never take shortcuts. Shortcuts should be taken when informed of the side effects that they immediately have and the pitfalls that you're setting yourself up for. So it's perfectly fine to say, this is gonna hurt bad in 6 months. In 6 months, we're gonna hate ourselves, but we need this right now. It's not fine to say, and we'll deal with it later. People need to, I would suggest you grow a culture of thinking through each shortcut and outlining what it means, and then weighing what the pain means in 6 months versus what you gain right now. Questions?
Do you live on the second floor?
I bet you almost nobody got that. You're the first person to make that joke.
So does it get better? How long does it take to get better?
Does it take better, and how long does it take to get better? What? The pain of dealing with software development and software developers and fixing a project like this. So it's impossible to fix a project like this because I'm not. It's impossible to be done because some amount of this nonsense happens during regular software development, even with the best intentions. We do not, as an industry, we do not have the benefit of going, okay, we're building a new bridge for New York. It's gonna, you know, we need it to last 100 years, and here's the projection of growth of New York for the next 100 years. The way our things go is in 6 months, you're either dead or you have 100x traffic. 100x is something that no city is ever gonna see. You know, no city has experienced 100x for the duration of the existence of its bridge, and in that time has not built additional bridges. So our industry is such that almost all solutions that we build are half bad in 6 months and completely outdated in 2 years. The important part is recognizing it. What I'm talking about here is the truly blind approach of who cares. So I don't think it's possible to completely fix any software project that is living, that is being currently worked on, and that is currently accruing both features and users. So it's very difficult to answer. But if you take everything that I talked about here as belonging to a single project, which I never said that it did, I would say coming in at the point where it's falling apart, where it's barely usable, where almost every single day there's a fire of some sort, I would say from that point to cleanup is about 2 years of work if you're still shipping features and onboarding people onto it. Yeah. Question here?
Okay, so let's get back to your pagination. So you said
we didn't talk enough about pagination.
Yeah,
okay,
maybe once every 5 seconds. And you said to return 101 records, that way not to return the total number of records. And does that mean that we will not have, for example, pagination 1, 2, 3, 5 page, that we will have only next, first, the previous, and that?
You can cheat around that, but yes. Any meeting in which someone says, and here we're gonna put the total number of, you should go no. First of all, no. Second of all, no. Third, no. If you Google search for a popular topic, you will see something out of, first 10 out of 40 million results. There's not exactly 40 million results. They are estimating. They're taking what they have and they're doing like, it's going to sound like, we know roughly how popular this term is. So they don't print out the actual number. If it is important to have that, for instance, on Twitter, on your profile, I keep going to Twitter because it's very small scope, but very, very intense. You have, for each person, you have how many followers they have. For that number, they're not doing select count out of followers because that's insane. But what they're doing is every time someone follows or unfollows you, there's a separate number that is being kept. So if it is mission critical, if it's absolutely crucial to the product, if it conveys real information, then you need to do that and keep the number separate. But what you will see in almost any large-scale product is that most of the time they don't do that. In Gmail, if you search for your name, you're going to see 1 to 20 out of many. They don't even bother. It says many. You have many emails with your name in it. So that's, yes, you should. So just to go back, you can cheat and print like 1, 2, 3, 4, 5, 10, and then like more, and then, so you can do pagination 20 at a time, but actually fetch 100 and figure out if there's more than that. But any product that prints you like that prints you the number of pages or anything like that is either keeping a record separately of the actual number or hasn't experienced real growth yet.
Yeah, and that by keeping it separately, it has to be well synchronized, because if somebody deletes a record or something and you forget to do it there, then...
Yeah, I mean, it is a common problem, but if you're thinking about this from the start, so the problem is if you have something adding and removing records, if you have many things adding and removing records, and then at some point you go like, okay, that select count is really slow, we need to replace it with something. And then you're playing whack-a-mole with finding all of the places that touch the data. If you do things right from the start and you have a single place in charge of those records, it's very easy to add that. But the best thing would be to have a conversation with product and design and whoever is pushing this and go, is this something that is crucial? Is this something that we absolutely have to have, or something that you had as an idea while having your morning coffee? If it's something we absolutely need to have, then from the start we're going to have to do this, and it's going to take 3 more days of engineering time. If it's not, then just drop it right now.
Thank you.
And we have time for one more question.
Well, it's not actually a question, just going back to how much time it takes to fix some leaks. So actually in the previous company we had a few of these problems. So because we inherited an already made project that was in 2015 done in PHP, because why not?
Okay.
So we had to rewrite everything, but we also inherited the databases and the structure. So it took us around 3 years to fix most of the problems, which means first, put some indexes in the databases because they are very useful. Splitting the API instances from the database instances because they might need to scale at different speeds, and also you need to replicate them. Also, one user can have multiple accounts, so they shouldn't be one-to-one. One user can have also multiple social accounts, so again, that could be, that shouldn't be one-to-one. But then it was all in production, and we had around 1 million users totally. Yeah, it took us 3 years, and we're still not done. We're just,
that sounds about right for a user-facing. So the thing that I was talking about is purely an internal product. So it's a lot easier. It's a lot less of a problem if you break it for an hour. There's a Slack channel, and you go, hey guys, I broke it. Take 5, everyone. Be right back. It's a lot easier to quickly iterate. It's not a mobile API, so you don't have 10 versions of the mobile app out. You don't have to maintain. So like with what I'm talking about here, we can break the API and say, hey everyone, I broke the API, please refresh. which is something that you can't do with with something that is living outside the company. So yes, 3 years sounds about right for that kind of pain. And for the multiple accounts, that's something that user-facing products often get wrong. Cloudflare only implemented being able to log in with one set of credentials and accessing multiple Cloudflare accounts this year. I think it's less than 6 months old, this feature. So it's a common thing, yeah. Okay, and that is time.
Yes.
Thank you.
Thank you.